Hi, and welcome to another video tutorial. In this video tutorial, what we're going to be talking about is public versus private IPv4 addresses. So the difference between public and private IPv4 addresses, and that will lead me into later on in this video talking about something called NAT, or Network Address Translation, which is very closely related to this. Okay, so what is a public address then? So a public address is sometimes called a global IPv4 address and is used for transmission of IP packets across the public internet. Okay, so public IP addresses are used for transmission of IP packets across the public part of the internet. But there are ranges of IP addresses that are set aside as private network addresses. And what this means is that these addresses can be used internally within a company, organisation or home network, so a private network, but they can't be used for transmission across public parts of the internet. Okay, so these IP addresses, address ranges from Class A, Class B and Class C are all designated for use on private networks and can't be used on the public internet. So, have you ever wondered why you always seem to see addresses being used on networks that start with 192.168, or maybe one of these other ranges as well? That's because these private network addresses can be used on any private network. So I could have the same my computer internally within my home network could have the same IP address as my neighbour's computer internally within their home network, and that's why you often see you do see these 192.168 addresses being used all over the place, but they can't be used to send packets on the public internet. Okay, so now I'm going to talk about NAT. And what NAT is stands for Network Address Translation. Is a system that was introduced to overcome the shortage of IPv4 addresses, or to delay the need to bring in IPv6. So it's used to extend the life of IPv4. What it's basically allowing you to do is have one public IP address for a whole network. So, for example, in your home, you might have one public IP address used to send all of the traffic to the outside world, and you're essentially able to, using that, use that public IP address, the same public IP address, for all of the different devices that are connected to the internet in your house. So how does it work? Well, it uses a NAT box, and this is a device. It's usually part of routers nowadays, and the NAT box is used to perform a translation between a private IP address and an external public IP address. So in principle then, what happens is that a company, an organisation, a home or some other private network is allocated a single IP address for traffic that's being sent over a public network like the public internet. And then what happens is devices on that network use private IP addresses for communication internally, and then NAT is used to translate those private IP addresses into the single public address. So, just to recap there, a private network is allocated a single public IP address, and NAT is used to allow multiple hosts to use the same public address. So you might be wondering at this point, if you have multiple hosts on a private network and a NAT box is translating every private address into a single public IP address, how does the NAT box know where to send replies received from the public internet? Well, the way this problem is overcome is we use what's called port numbers. And one solution might be, you might think of, is to use is to store the private IP address in the packet as well as the public IP. But there isn't enough room in an IP packet to do that. So what we need to do is use the port numbers. Okay, so another question you might have come up with is when you're thinking about this NAT translation is, what if two PCs request to send a request to the public internet using the same port, like port 80 for example, for HTTP? I'm going to try and answer those questions at the same time with this diagram here. And in this scenario, what we've got is two PCs sending a request to the public internet, and we've got two different servers here, and we've got the NAT box in the middle. And the NAT box has what's called a translation table, and the translation table records the port that a request is being the associated port of a request on the outside of the private network, and the port associated with a request on the inside of a network, and the private address. Then what happens is that that request, the private address gets stripped off of that request, and the public address gets put on, and then it is sent off into the public internet. So let's just fill in this bit of the table here, and we'll see what's going on here. Okay, so these two addresses here, the source addresses, so these are the private IP addresses of these two PCs. This PC has the private IP address 192.168.10.1. This PC has the private IP address 192.168.10.2. And they're both sending they're both wanting to send a request to a server. We're going to say on port 80, and those servers have different IP addresses, public IPs. So we're going to write those IP addresses here in the destination field of this table. Okay, so there's some random IP addresses that might be public IP addresses. So the destination of the what the port associated with the destination IP here is going to be port 80. So if we're sending typically an HTTP request, we're going to send it on port 80. The source port is just a number that's chosen fairly randomly by your computer. So this might be 2000 here as the source port, and this might be 4100. Okay, so now we've got the basics that's going to allow us to fill in the rest of this diagram. So we've got, just to recap then, we've got this PC is sending a request to this server here with this public IP address. The private IP address of this PC is this 192.168.10.1. The source port, chosen fairly randomly by your computer, is going to be 2000 in this case. And we're sending an HTTP request to this server, so we're going to send it, so the destination port is going to be port 80. And then this is the same, except different IPs and source port for PC2, both sending HTTP requests. Now let's look at the NAT translation table. So for PC1's request, the IP address inside the network associated with this request is going to be 192.168.10.1, because that's the private address of this PC. We're then the inside port of this request is going to be 2000, and then we're going to leave the outside port for a second. The inside port of the request for PC2 is going to be 192.168.10.2, and the inside port is going to be 4100. Now, what the NAT box does is it also changes the port number. So the source port number. So the NAT box has chosen two outbound port numbers for our requests. Okay, so let's now take a look at what it looks like between the NAT box and the server, then what each request looks like. The source address here in this request is going to be the public IP address for this network. So let's just say that that is 10.20.41.60, and that's going to be exactly the same source address as for this one, because NAT is translating to one public IP address. So these are going to have the same source address because they're coming from the same private network. Now the source port is going to be different. The source port is going to be the outbound port that the NAT box has allocated the request here. So the outbound port for this, the outbound source port for this request is going to be 5800. The outbound port for this request is going to be 6800, and the destination IP and port number are going to be the same as they were with the request sent by the PCs. So here it's going to be 112.100.110.90. Here it's going to be 111.101.90.68, and they're both port 80. Okay, so this is quite a complex process, NAT. The main thing you need to remember is the fact that what NAT does in principle is it allows a single public address to be used for communication between multiple hosts and the public internet. So, for example, if I'm at home and I've got 5 computers in my house, I can use one public address to communicate with the internet for all of those computers using the NAT system. And internally within that network, they're just using private IP addresses which can't be used on the public internet. And from this diagram, what you'll be able to see is the NAT system works on the port numbers. So because we can't store the private address of every host on this side, on the internal side of the network, in IP packets being sent around on the public internet, we can only store the public IP address here, because we've only got room for one IP address. So we store the public IP address of this internal IP network, and we use the port numbers when requests are coming back to distinguish which PC the incoming packets to the network should use. And the way that works is when a request comes back from server 1, for example, the request will come back and the destination port will be the source port here. So the destination port will be 5800. The NAT box will look up that in its translation table, find that the internal address here is 192.168.10.1, find that the internal port number is 2000, and then it will send it to the correct host on this internal IP network. Okay, so I hope you found this tutorial video useful. Do please leave any questions in the comments about particularly about this NAT diagram, and I'll try and answer them as best as I can, because I know this is quite complicated, and I certainly had a lot of questions when I first learned about it. Okay, so I hope you found this tutorial video useful, and thanks for watching.